Hey, what's up, guys? This is Sheng here. So today, let's take a look at LeetCode number 638, shopping offers. Okay, so you in LeetCode store, like there are n items to sell. Okay, and each item has a price. But we also have some like special offers, and the special offer consists of one or more different kinds of items with a sale price. Basically, with a sales offer, you can use this sales price to purchase multiple items at once or all together, right? And then you're given like an integer array price, where the price I is the price of the ith item, okay? And the integer array needs, okay? The needs means that that's the total number of items that we want to purchase, okay? And then for this special, for the specials, it's a list of list, okay? Where the special I basically it's just like an offer, right? And the list inside this special offer is the length is n. Basically tells you for this special offer, what are the items you can buy within this offer. And so the reason we have n plus 1 is because for the 0 to n minus 1 is all the items we can buy for this offer, and the last one is the price for this offer. Okay, and then you need to return the lowest price, right? You need the lowest price to buy exactly this needs items. You cannot buy less or more. You have to buy exactly this many items. And one of the constraints that you're not allowed to buy more items than you want, right? Even if that it would lower the overall price. So which means that let's say in this special offer here, for example, in this offer, so with $5, you can buy the first item and 0 second item. So let's say in this case we have 2 items left. We have the 2 first items left. And then you cannot use this special offer because 3 is greater than 2, which means if you use this offer, you're buying more than we need, right? That's why in this example 1 here, right? So we want to buy 2 of first item and 5 of the second item, and we have 2 special offers here, and sorry. So this is the price. This is not the need. So the price is 2 and 5. We want to buy 3 first items and 2 second items, right? Yeah, I mean, maybe I should use this. I should have used this one. That's why in this example 1 here, right? The answer is 14 because the best strategy for us to use these special offers. And we can use special offers as many times as we want, right? So there's no constraints for that. Is to use a special offer 2 to purchase 1 of first item and 2 of second item. So after using the special offer number 2 here, we only have 2. We're gonna have 3, 2, right? So after using the second special offer, we have 2, 0 left, right? And that's why then we'll use $10 to purchase this one, and then plus we have 2 left. For 2, see there's no other special offer we can use. That's why we have to use the price to purchase the remainings, right? That's why we have 2 times 2, which is 14. It could also be that the special offer will end up spending more than directly using the price, right? Because as you guys can see, right, so the price could be 0, right? So it means that there could be a possibility that all the price are 0. So which means that we will not even use any special offers. We'll simply just use $0 to purchase all the items we need, right? And here are some constraints, right? So we have it's not that big because so we have kind of an we only have like up to 6 items we want to purchase, and for each item, the amount is like 10, right? And the special offer is like up to 100, right? So for this problem, obviously we can use the DFS, right? Basically, we can just simply the starting state is like it's the 3 and 2, right? At this state, we have many options. We can try to use any of the special offers, right? And once we use that, the needs will be updated, or we don't want to use it, right? Or if we don't want to use it, it means that we want to use the price to purchase everything. Okay. Then we can, at each of the state, we can just simply try out the possible scenarios, right? But it turns out that we can memorize the result, right? So the reason being is that given like a state, so a state is what? State is the remaining items that we want to purchase, right? So let's say we have like this kind of items, right? Let's say we have 5 items we want to purchase. Given like a state, a number of these 5 items left, let's say 2, 1, 0, 4, 5, right? The minimum amount that we need to purchase this given state of the items is fixed, right? So which means that at the beginning, let's say we have 9999, right? We have this is the starting state, right? We could have multiple like branches that can lead us to the same state here, because we have multiple special offers, right? The combination of the uses of different special offers can may lead to the same state, right? Could be like this, and then here, right? Or this, and here. So then, as you guys can see, you're right. If multiple different paths lead to the same state, we shouldn't recalculate the state, right? So which means we can just memorize the result, right? Hence, this is like actually it's a top-down DP problem, right? Where the state is this kind of, it's the current needs, right? Yeah, I think that's the only state we need to maintain here, because there's no other state, and we have to maintain all the numbers here, because the sequence also matters. And yeah, so that's why we cannot use the bit mask, because not only we need to maintain all the numbers, but we also want to maintain, we need to maintain all the different numbers on each of the state. It's not like a 0 or 1. It's not a peak or not peak. That's why we cannot use bit mask. So we have to use a tuple to memorize this kind of state. Okay, cool. So then we can start coding then, right? I mean, since we're going to use the top-down DP, right? So we have a needs here, right? And there's going to be LRU of cache none, right? And then we have an n going to be a length of price, okay? And then we're going to return DP, right? In Python, since you cannot use a list, you cannot use the list, because a list in Python is not hashable, because it's immutable. That's why if you want to hash it, right, or you want to basically store it by using this kind of Python's decorator, you have to convert it into a immutable data structure, which is the tuple. Okay. So, and now, right, I'm going to convert it back to the need list, because we need to update it based on the special offer, right? So for the special offer, basically we have first special in specials. We need to check each special offers. And then here we have to return the answer, right? I'm trying to write the main logic here, right? So the answer is, at the beginning is the system max size. Okay, but okay, one thing to be careful is that, as you guys can see, we have, two set of options we can take here. We can either try to use one of the special offers at the current state, or we can just use the price to purchase the current one. Okay, to use a special offer is kind of straightforward, right? If we take that special offer, we just subtract everything from the special offer, right? And then we increase the price by that special offer. But for this kind of, if we don't want to use the special offers, which item we want to buy with a price, right? If we try to write another for loop here, for each of the items, and then we try to decrease the items one by one, that will definitely TLE, right? Let's say we have this many of items here, So for this kind of a scenario where we want to use the price to purchase any of these items, and if we want to use this one, to purchase this one, if we only decrease it by one, so let's say we have 5, 5, 5, 5, 5, 5, right? So if you want to use this one, so let's say, okay, so next set will be 5, 4, 5, something like this. And then we also we can also have like this 5, 4, right? 5, 5, 5. If we try to enumerate the scenario in this way, that'll be too much. That'll be too much for us to calculate. So it turns out, actually, if we don't use a special, we can simply just use, assuming we want to use a price to purchase everything in the needs here. So the reason being is that, because at each state, we only need to calculate this thing once. So this is what I'm trying to say here. Basically, the base case will be like this. So we're going to be sum of the need list of I, right? Price times the price I for I in range of n. So here I don't use the use price, regular price, okay, to purchase everything. So the reason being is that the reason we don't need to purchase items once at a time is because, like I said, we only have two options, right? So we either at the current state we either choose a special offer or we don't choose a special offer, right? So which means that, we don't have to purchase items one by one and try to purchase each items, try to purchase item for each of the need, right? We can simply, assuming we want to purchase everything with a regular price. Because let's say the final end is we want to use special offer 2, right? Plus special offer 1, right? Plus special offer 5, okay? And then plus the regular one, right? As you guys can see, so let's say this is the final state. Basically, it's the optimal final state that can give us the minimum total cost, right? As you guys can see, we will only have one regular purchase regardless, and all the others are the special offers we will be using. Okay, so which means that, at each of the state, actually there's no need to try to use a regular price for each of the items, because we can simply assuming, right, and there will only be one case that will be using the regular price. It doesn't really matter which one it is or where we'll be using that regular price, since we will try using the regular price at each of the state. So this means that, with the given state subtracting the special offers, we need the rest will be everything. Basically, there will always be a state that will be using the regular price to purchase all the remaining items. That's why at each of the DP state here, we can safely use this assumption here. Because like I said, there won't be like a two regular purchase here, right? There always going to be one. Okay, so that's a improvement here, right? And here try to use a special, right, offer. Okay, so to try to find a special offer, there's some like tricks, small tricks we can use here, because for the special offers, we will be subtracting the numbers from the special offers. But since we're trying all the special offers, this is a little bit of backtrack here, right? Once we subtract from the special offers, we need to put them back. Okay, so for my case, I just have two for loop here for the backtracking. You can do it in your own way, it doesn't really matter. So need list of I, right, minus si, right? So the special offers. Basically, if the need list I is smaller than 0, right, it means that we cannot use this special offer. But I don't want to break here, because I will need to put them back. If can use, so, and if this one's smaller than 0, it means that the remaining need is smaller than the ones in the spec than the offer, which means we cannot use it. Okay, so here now we can do a backtracking with a DFS, right? So the price we're gonna accumulate is S minus 1, which is the last element for the special offer, right? And then the updated needs will be when we convert it back to this tuple. Okay, and then when do a backtrack, we add them back. Okay, for I in range of n, do a need list of I, right? And then we do this si. Okay. Yeah, I think that's it. If I run the code, okay, accept it, right? Right, cool. So it passed, right? So for the for the time complexity, for top-down DP problem, the time complexity always equal to the number of states times the time complexity inside this DP, right? So for the states here, right? We have six number in total, and on each of the numbers we have up to 10 values. So the worst case scenario, the needs will be what? The state will be 10 to the power of 6, right? Because at each of the state at each of the number we have 10, and we have 6 in total. And then inside here we have a for loop here, right? Because here, n is like only 6, but for the special we have 100. So that's why we have a 1 times 100, right? And inside 100 we have this kind of n here. It's going to be a times 6, I think, right? Yeah, there's a for loop here. For loop out of 6. So that's going to be the worst case scenario, time complexity. This one is pretty big, but I think in reality, we won't, since we have this kind of offers, basically we won't we won't explore all the 10 to the power of 6 states, because for the offers we usually just will decrease multiple like items, the numbers at once. So this is the worst case scenario, but I believe we won't need that many scenarios, because at least based on the test case, we'll not explore all the sub problems. That's one of the feature of the top down DP, is that we only explore the necessary sub problems. We won't be able to go through all the possible sub problems, right? And for space is basically the number of the states here, right? It's going to be a 10 to the power of 6, yeah, times what? Times times 6, right? Because the length of the tuple is 6, so this is the time and this is space. And yep, I think that's it for this problem. Okay, and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.